Hello, Algebra 2 friends. It's me, Mrs. Bruno. I don't know who else it would be, but I just felt the need to tell you that today. And we're going to talk about quadratics. Quadratics are one of the biggest Algebra 2 topics that most people think about when they think of Algebra 2. And we're going to start by solving them by factoring, okay? So first, we're going to review this. I did give you an assignment on factoring. If you did not do it, shame, shame. Because you need to be a superstar at factoring. So these are the 4 problems. You could try to do them on your own and pause it if you want, but we're going to go look at them on the next slide. Okay, so when you're factoring, there's all different types of factoring it could be. And we always look for a GCF first. And this one does not have a GCF, so you're sad. Then you're also sad a little bit because this 16 is in front. Usually when there's not a number in front, the problem is significantly easier. So this one has a number in front, which I'm a little sad as well. So then I'm kind of hopeful. And when I notice that it's a 16 and I notice this is a 1, this is what we call as a PST, or a perfect square trinomial. And this is not difficult to factor as some of the guess and checking ones are, because the 16x will just be a 4x and a 4x. The 1 will be a 1 and a 1, because there's only one way to do that, and I need a negative 8x, so this will be a negative and a negative. Because it's a perfect square trinomial, it would really just be 4x minus 1 quantity squared. The quick check is 4x squared is 16x squared, negative 1 squared is 1, multiply them together, which is negative 4x, and double, and that gives us the negative 8x. Okay, this guy right here, easiest one for me to notice, but for some reason, kids sometimes do struggle noticing it. There's only 2 numbers. They are both perfect squares, and it's a minus sign. That is difference of 2 squares. And difference of 2 squares are my favorite, because you're going to get 1 plus and 1 minus, square root, so it's a 3x and a 3x. You get a plus 7 and a minus 7. These are called I don't know why I wrote a 3. These are called conjugate pairs. They're not opposites, just the second sign is different. And because of that, when you multiply them, the O and the I of FOIL cancel out, or the outer and the inner, and you're left with just 2 terms, difference of 2 squares. Okay, number 3 here, this is a typical, what we call a guess and check. It is a trinomial. It's not a perfect square trinomial. It's not a difference of 2 squares, and there's no GCF. So we're going to be doing guessing and checking. You'll make your list for negative 30. Some of you will see it right away, and gold star to you. You don't have to make a list if you know what you're doing. How can I multiply to get negative 30? 1 and negative 30, 2 and negative 15, 3 and negative 10, 5 and negative 6. Keep in mind, I also could have had negative 1 and positive 30, but I don't usually make both lists because that's a little extra for me, but this is the first example, so I'll go ahead and show you everything. And then you're looking for which one of these will add, because of O and I of FOIL, to give us negative 1, and this is the one I'm after. So then you'll have x plus 5 and x minus 6. Double check, always double check, x squared minus 6x plus 5x, that is negative x, minus 30. Okay, now this bad boy. This has a leading coefficient, and it's a trinomial. There's no GCF. So Mrs. Bruno loves the AC method. Okay, AC method is my favorite. You are welcome to just guess and check if you want, but the AC method is a way that it will always work. So the first thing that you can do is you can change the problem by multiplying the A times the C, which is why it's called an AC method. So I'm going to change this problem to x squared plus 17x minus 18. And this is easier to factor. I make my list for negative 18. 1 and negative 18, 2 and negative 9, 3 and negative 6, and it's not 1 and negative 18, that would be negative 17. So it's going to be negative 1 and positive 18. So I'm going to have an x minus 1 and an x plus 18. I left some space there. Well, why did I leave space? Because remember, I changed the problem. I took that 3 away. So I need to put the 3 back in both of the parentheses. Now, since you put it back twice, one of them should simplify out. The 3x minus 1 will not change, but the second one has a GCF of 3 in. So if I pull out the GCF of 3, I'm just left with x plus 6. I'll throw that 3 away, and I get x plus 6 as my second factor. So 3x squared plus 18x minus x minus 6, that will give me what I'm after, 3x squared plus 17x minus 6. If you need help with factoring, you really need to work on it. We're going to take a quiz over that later this week. So what are we going to do? We're going to find some solutions to quadratics. There's always these little underlines here because the guy doesn't give me a chance to take the picture. And we're going to solve word problems. Be fun, right? Sure. So quadratic functions. Well, what is a quadratic? Because some of you guys asked me that earlier this year, and I was surprised, but quadratics are something that can be written like this. Ax squared plus bx plus c equals y. Anything that can be written with an x squared, basically, is a quadratic. Now, it says function, so you can also use f of x here. And we know that f of x, if you graph it, you can use y. It is possible that b or c could be 0. So you could just have like y equals 2x squared. Or you could have 2x squared plus 1. But a can never be 0 because if a was 0, you wouldn't have an x squared at all and you would just have a line. So you have to have an x squared. Having an x is optional. Okay, so they have a quadratic for us right here. Get my pen back. And here it is. This is called factored form. So factored form here is y equals x plus 3 times x minus 4. Now that's called factored form because it's written with two factors. Standard form looks like this. This is called standard form. And standard form can be written if I would multiply these two together. So I would double distribute or FOIL, and I will get x squared minus x, because I'll have a minus 4x and a plus 3x minus 12. So standard form is good for something, and factored form is good for something. So what are they good for? Well, standard form is good for finding the y-intercept. Why is it good for finding the y-intercept? Because a y-intercept means x equals 0. And if you plug 0 into this equation, it's real easy to see that the y-intercept is negative 12. Standard form is also good for typing in your graphing calculator because it's the easiest form to type in your graphing calculator. So those are the two things it's good for, y-intercept and maybe your graphing calculator. Other than that, standard form kind of stinks. Okay, now factored form is really awesome for another reason. Factored form is good because factored form is good for finding the x-intercepts. And we're going to talk about that here in a second. Factored form is good for finding the x-intercepts. And as you can see here, I have negative 3 and 4. So how is the negative 3 and the 4 related to this factors? Well, it's basically the opposite of that number and the opposite of that number. Why is that the case? Well, x-intercepts mean y equals 0. So if I solve this equation and I have 0 equals x plus 3 times x minus 4, the things that will make that true will be negative 3 or positive 4. How come? Well, negative 3 plus 3 is 0. These two things are being multiplied by each other. So if you take 0 times any number, you'll get 0. And if x is 4 here, if you take 0 times the number here, you'll get 0. So if you can get factored form, that's two things being multiplied by each other. You can find the x-intercepts by making y equals 0, and that is a special property that we're going to talk about here on this next slide. Okay, so what is a 0? In math, we have all these vocab words, and sometimes we call things different. So a 0 is another name for an x-intercept, but sometimes we just call it a solution. So why would we call it a solution? Well, I just kind of talked to you about that. If I have the x, was it x plus 3? I don't remember, but let's pretend it was. X plus 3, x minus 4. A 0 is another name for an x-intercept. We sometimes call it a solution because if you say 0 equals x plus 3 and x minus 4, we're going to solve it for x. So we call it a solution because it's the answer or the solution when y equals 0. What does an x-intercept mean? It means that y equals 0, find x. And do all quadratics have 2 zeros? Well, let's think about it. A quadratic is a parabola. So the parabola we just looked at definitely had 2 zeros. I see them right here and here. But isn't it possible that my parabola could be up here? Where are the zeros here? Doesn't seem like we have any. And we're going to talk more about that later this chapter. It is also possible, and we will see this section, I think, for it just to have one x-intercept if it was sitting right on the x-axis. We call that tangent. If it touches in one point, that's that word tangent. And so sometimes it might just have one x-intercept or one solution. We actually call that solution a double solution or a double root because that's another name for x-intercepts are roots. So you have root, you have x-intercept, you have solution. There's all sorts of things we might call it. So if you get confused by what I'm asking for, just make sure you ask because we got 0, root, x-intercept, and solution all kind of meaning the same thing. The biggest difference is the 0, we would just say is -3 and 4. If it was an x-intercept, you would actually write it as an ordered pair. So really, the answers are kind of the same, but for zeros and solutions, we would just say x equals this. For x-intercepts, you would write it as an ordered pair because x-intercepts are technically points. I don't think we'll get too tricky about that right at the beginning, but those are just things to start thinking about. So this is called the zero product property, and this is why the factored form is good for x-intercepts. We are going to solve it. Notice there's not a y here, so I'm just going to say solve. But they put 0 where the y was before, so that's why the solution is kind of like where the x-intercepts are. But usually when we say solve, you all know what we do. We get x by itself. However, what the heck are you supposed to do? I got an x squared and an x. Many students, the first thing they start to do when I say solve is they add 30 to both sides, and then you get stuck. There's nothing you can do because when you solve a quadratic, you frequently cannot get x by itself. So we're going to teach you some strategies. And the first strategy we're going to teach you is to factor. So if they say solve and you can factor, that's what you're going to do. So you make your list for -30, and we did this earlier, and we decided that it was -6 and 5. So this guy is the exact same thing as x minus 6 times x plus 5 equal to 0. This is standard form. Fun fact, y-intercept is 0, -30, and this is factored form. Factored form is good for finding solutions and for finding x-intercepts. So what the zero product property tells us is basically what we were just talking about. This is a number times another number. X minus 6 represents a number as long as you plug something in for x. X plus 5 represents one number as long as you plug something in for x. If it's going to equal 0, one of these numbers has to be 0 because 0 times a number is 0. So what this really tells us that is this x minus 6 equals 0 or x plus 5 equals 0. These will be my solutions. A lot of kids want to just memorize, oh, it's the opposite of this. Sure, you can do that, but sometimes we're going to have numbers in front of the x. So you really need to understand that that whole x minus 6 equals 0, and that tells you that x equals 6 or x equals -5 is the solution. And you get it from solving the factors. You set them equal to 0 and you solve. This also tells us that the x-intercepts would be 6, 0 and -5, 0. Those would be the x-intercepts. These would be the solution because if I plug 6 in here, 6 minus 6 is 0, and 0 times anything is 0. If you plug -5 in here, this would be 0. 0 times anything is 0. Okay, so what do we do when factoring is tough? We do that AC method we talked about. So we're now going to solve that equation that we looked at earlier. Just a reminder, if I told you to get x by itself, adding 6 will do nothing for you. You are not able to get x all by itself. So our only strategy that you have at this point, unless you remember things from your Algebra 1 days, is to factor. And you see this and you hate it because it's so hard to factor. So we're going to change the problem using the AC method. X squared plus 17x minus 18 equals 0. But that's not the same thing as before. Just keep that in mind. So we factor the negative 18, and I could stop right there. This gives me negative 17. I need a negative 1 and a positive 18. So this is what I need. So I leave myself some space because I remember that I changed the problem, and I have x plus 18 here. Why did I leave space? Because when I changed the problem, I got rid of the 3. You got to put the 3 back. Then you put it back twice instead of once, so you need to see if anything factors. There's a GCF here. They both have a 3 in common. That leaves you with an x plus 6 as your second factor. So we have this guy is the same thing as this guy. This is standard form. Remember, standard form is good for y-intercepts. The y-intercept of this guy will be 0, negative 6. This guy is factored form. It's good for finding solutions and finding x-intercepts. So how will I solve this? Well, this times this equals 0. So either 3x minus 1 equals 0 or x plus 6 equals 0. You got to be careful with the life hacks. Like I said, some of you might want to just say, oh, it's the opposite every time. And that works on the second one, x equals negative 6. But if you told me x equals 1 here, that's not true. Because if x equals 1 and you plug it in, 3 minus 1 is 2, and that's not 0. I need to know what will make it 0. So if you add 1 to both sides, you get 3x equals 1. Divide by 3, and the other solution is x equals 1/3. Okay, the shortcut, if you are a shortcut liking person, will always be the opposite of this sign over the coefficient of the x. So you can check your answer by plugging in 1/3. 3, I got a little glitch there, times 1/3 minus 1, does that give you 0? Sure does. Definitely the negative 6 gives you 0. So these are my solutions. If I was going to graph it, 1/3 0 is an x-intercept, and negative 6 0 is an x-intercept. Because quadratics in factored form are easy to find the x-intercept because that means y equals 0, and that's where the y would be if I had an equation. Okay, so let's look what else we have. How can we check? We plugged it in. What would a graphing calculator do here? So let's escape out of here. I don't know, sadness. Escape. Come on, Bruno. I don't have my 84 up. I never do. You guys are always probably like, get your stuff together. We're going to go ahead and look at your graphing calculator because your graphing calculator can tell you if you're doing these problems correctly. So you're going to type into your y equals 3x squared plus 17x minus 6. As soon as it loads up here, y equals, clear this out, 3x squared minus 17x plus 6. I'm going to go to Zoom 6, my standard Zoom, and it's not all in the picture, okay? I do see that 6 is my y-intercept, which I knew, so I kind of feel good about that. And if you look here, did I type the equation right? 3x squared plus 17x. Sorry, minus 6. Now let's graph. So it should be at negative 6. Definitely a different graph here. So there's the negative 6. This looks like it's going through negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And this is definitely in between here, okay? Your calculator can tell you if you're right or not. You could go to the table. If you go to the table, let's set it up. Let's go to table set. Let's start at 1, and let's go by ones. Oops. Okay, we're looking for 0 here. There it is, -6, 0. Now the second 0 you can see will come between 0 and 1. So you could change your thing to go by 0.1s, but you're going to have a hard time getting there because it's 0.3 repeating. So let's go back to our graph and see what other option we have. If you want to use your calculator, you can hit second, trace, second, calculate. And what we're looking for is this 0, number 2. We already know this one is -6, but we don't really know what this one is. So remember, when it says left bound, you have to tell your calculator where you would like it to start looking. So you need to make sure your cursor is on the left side of this 0 that I'm looking for. Mine is, so I'm going to hit enter. Now it will ask for a right bound. So hit the right arrow until you are on the right side of that point. And I'm now on the right side. Once it was below and once it's above. Do you see how my arrows are pointing at each other? Because it's only going to look in between there for that 0. If you want to hit guess, you can move your cursor closer to it if you want. And there it says 0.3 repeating. You need to know that's 1/3, but it's a nice way to check to make sure you know you're doing it correctly. Okay, what else we got here? How can you describe the solutions? Okay, so this guy, what does this do? We already factored this as well. We recognized it was a, my battery's low. We're going to see if I can make it here. Perfect square trinomial. It was 4x minus 1 quantity squared equals 0. Okay, so how do we find the solution here? Well, that's the same thing as 4x minus 1 times 4x minus 1. So what is happening here is that I'm getting the same answer 2 times. 4x minus 1 equal to 0. If I add 1 and divide by 4, I get 1/4, but I get that 2 times. So I get x equals 1/4. I'm only going to get one solution, but it's called a double root, like I said. And what happens on problems that look like this is they will be tangent or they will bounce on your x-axis. So this is called one real solution. You can say a one real solution or a double root at 1/4. Okay, I don't remember exactly what they wanted you to say, but we're going to go with that for now. Okay, so let's talk about problem solving. Okay, problem solving with quadratics are kind of fun. When the product, which means multiply, 8 and the square of a number is decreased by 5, the result is the product of -18 and the number. Okay, so let's see if we can write this equation. I'm going to take 8 and I'm going to multiply it by the square of a number. I'm going to decrease that by 5, which means subtract 5. And what am I going to get? I'm going to get -18 times the number. So how can you solve this? Well, you cannot get n by itself because you have an n squared and an n. So what we're going to do instead is we're going to get 0 on one side, and we're going to hope that it factors because that's our only strategy we have right now. So I'm going to add 18n to both sides, and I get 8n squared plus 18n minus 5 equals 0. There's not a GCF, so you might be a little sad because we're going to have to do the AC method. So take the 8 times the -5. I get n squared plus 18n minus 40. Make your list for -40. 1 and -40, 2 and -20. That gives me -18. I need a positive 18. So let's do an n minus 2 and an n plus 20. That gives me the positive 18 I need. Don't forget, you changed the problem. So we need to put the 8 back 2 times. Now look, this is unique because they both have a GCF. What do these guys have in common? A 2. That leaves me with 4n minus 1, and you're going to throw away that GCF. These guys have a 4 in common. What does that leave you with? 2n plus 5, and you're going to throw that GCF away. in your factored form is 4n minus 1 times 2n plus 5, and we're not forgetting that that equals 0. Well, that's tricky because we still aren't done. We still need to solve. So if this times this equals 0, then I'm going to have to go over here, sorry. 4n minus 1 equals 0, which would give me 1/4, or 2n plus 5 equals 0, subtract 5, divide by 2, and n equals -5/2. Those are my two answers. Now, it seems kind of silly that those were the numbers I picked, but you should be able to check to see if it's right. Plug in 1/4. What's 8 times 1/4 squared minus 5? Well, in my calculator right now, I'm typing 8 times 1/4 squared. You will need to use parentheses around your 1/4, guys. Subtract 5, hit math 1 if you want, and I get -9/2. And my battery says it's low. We're going to hope it works out here. Does that equal -18 times 1/4? Yeah, -18 times 1/4 is -18/4, which is also -9/2. So they are equal, and this one works. Try the second one as well, and you'll get the same answer, but I'm kind of all out of work room here, so we're just going to assume that that second one is right. Okay, here's another word problem. The length of a rectangle is 4 more than the width. So here's the width. The length is 4 more. The area is 60. What is the length? Well, you take length times width to get area. So that will be W times W plus 4, and that's going to equal 60. I cannot get W by itself. So we're going to clean up, and we'll get W squared plus 4W equals 60. There's a W squared and a W, which means I need to get 0 on one side by subtracting 60 and factor. So I take my -60 and I start breaking it down. 1 and -60, 2 and -30, 3 and -20, 4 and -15, 5 and -12, 6 and -10. That gives me -4. I need a +4, so -6 and +10. So we have a W minus 6 and a W plus 10. That equals 0. So that means W equals, one of those has to be 0, 6 or -10. But think about what we're talking about. We're talking about the width. Can you have -10 as a width? Heck no, you can't. So the width is 6. What will the length be? 6 plus 4, which is 10, and 6 times 10 is 60. So that's how you can use a quadratic to model an area problem. Now there's this guy. This is a very famous formula that you will use sometimes, and this is for projectile motion. The little O here, we call that V sub O. That's how you say it. Or sometimes sub-zero, I say V sub O. Some people call it V naught, which also means sub-zero. And what happens is in physics, they like to use things like V1, V2 for different velocities because you're dealing with velocity a lot. This is what is called the initial velocity. So V sub O is just a fancy variable, has nothing to do with 0. The 0 is there to tell you its initial velocity. T is going to stand for time, and it will be there twice. And H sub O is the initial height. So that little sub-0 usually talks about initial things. Now, when you have a projectile, like there's lots of things that projectile, vomit, bullets, an arrow, a ball off of a bat, it makes a parabola form. Okay, it's a frowny face parabola, so that's why there's a -16 here. And the reason it's a parabola is because there's something pushing that ball down. You got some power going up, and then all of a sudden things are pushing it down because gravity is affecting it at -16. I think it's like meters, all right, it's 4.8 meters. I think it's I don't know. I'm not going to say something wrong, but it has to do with gravity. Okay, so a man throws a ball into the air, and the initial velocity is 50 feet, and that's where this came from. The initial height was 6 feet because he's probably 6 feet tall. And if you notice, that's where that y-intercept would be like at 6, because you can't quite tell because that's where he was. T is time here. X and T are time. So when he started here, it's really like the parabola should start here and then go. But if you can see, what's happening is he threw it, and then what happened? Time went on. So things we know by looking at this, we know that it took less than 5 seconds to do what? What's happening here? This is the height. This is the time. It took less than 5 to get to the ground. We also know how high the ball got. It looks like it got, this is 50, maybe 45 feet. Okay, we know he was 6 foot when he let it go. It went 50 feet per second. It got to a height of 45 feet, and then it came back down to the ground at maybe 4 seconds or so. That's what the graph is telling us. So Sharon kicks a ball from the ground with an upward velocity of 64 feet, which is why the 64 is there. This is the function this time. There's no y-intercept here because she kicked it from the ground, so it would be like a +0 at the end. They want to know when the ball will hit the ground again. So when will the height be 0? So that's -16 t squared plus 64t. You hope that it factors, and it will. This one has a GCF. So you can pull out what they have in common, which I'm going to go with a -16t. That leaves me with a t here. Since I'm pulling out a negative, that makes this a negative. 64 divided by 16 is 4, and these are the same thing. So that means if I solve it, this guy equals 0, or this guy equals 0. Well, for the first guy to equal 0, it is 0, and that's when it started. That's when she kicked the ball. When will it hit the ground again? At 4 seconds. That's when it will hit the ground again. I think that might be it. Yep, here are the key concepts we talked about. You can factor equations to find the x-intercepts. Standard form is good for the y-intercepts. And you can use factoring to help us solve. You can write word problems, and you should probably check them to make sure the answers are correct. That's it.